All right, we are talking about symmetry. And so I'm going to explain about symmetry, and then you're going to go back and have a go at using a ruler to draw in all the possible axes of symmetry. So what are we talking about? Symmetry is essentially how many ways can you fold a shape in half so that the two halves match exactly. So the number of creases formed will be the number of lines of symmetry. So for a square, the order of line of symmetry, let's move down here where I have a little bit of space. If I had a very nice square, I'm going to use my ruler and make a square. A square has a line of symmetry. Let me change the colors here. A line of symmetry down the middle here. So that's one line of symmetry, because if I folded this over, then it's going to be exactly the same. It's going to match up exactly the same. But I don't want to draw that line there. I'm going to draw that line there. But also it has another line of symmetry this way. If I go across this way, if it were actually in the middle, and I folded this half over onto that half, then that's another line of symmetry. Now this is a square we're talking about. So because all the sides are equal, I actually have another line of symmetry that goes this way, so across the diagonal, and another line of symmetry. So I've actually got 4 lines of symmetry, 4 creases where I can fold a real square. So that's what we get when we get the order of line symmetry. So how many lines or creases can we form for a square? And that is 4. Now the order of rotational symmetry is similar to that, but instead of drawing lines, we're going to locate the center of the shape and rotate the shape 360 degrees. Now as we rotate that around in circles, how many times before we get to 360, or including 360, does the shape make an exact copy of itself in its original position? This is the rotational symmetry. So going back to our square, okay, we know we have all those lines of symmetry, but now let's look at if we rotated it. So if I rotated this square, what's a quarter of 360? 90 degrees. If I went 90 degrees and spun this around, I wonder if I can do that. Anyway, if I did that, it would still be an exact copy of itself. So that's 1. In fact, I can do that 1, 2, 3, 4 times at 90 degrees, and I would have an exact copy of that square. So that means that, I'll get my pretty colors out again. So that means that the rotational symmetry of the square is also 4. Now, remember this is a square, so this is a pretty special case. That's all equal on all sides. Let's look at the rectangle, okay? So, just to recap, an axis or line of symmetry divides the shape into 2 equal parts. So if this line of symmetry on the isosceles triangle, if I fold it across from one side to the other, ooh, angry face, it's not the most angry face, then they would actually overlap each other directly. Now this one is an equilateral triangle here, and if we looked at the order of rotation, the number of times the shape makes an exact copy of itself in its original position when you rotate it 360 degrees. So this shape, if I rotate it a third of 360, and then again, what is a third of 360? 120. And then another 120, it will always come back to this. So there's 3 opportunities that we can get an order of rotation. So the order of rotation is 3. If there's no rotational symmetry, the order of rotational symmetry is equal to 1. So if I can flip any shape around 360 degrees, I'm going to get the same shape again. So let's look at a few examples down here. Let's get rid of our friend, the square, because we're done with him. All right, let's look at the rectangle. The rectangle I can see right away. If I draw, let's hope this is in the middle. Boop, 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 boop. Boop, boop, boop. Woo, that is a wonky line of symmetry. But there's one, what is that one called? Let's look at the words. Line of symmetry. So there's one line of symmetry. If I folded those 2 along that crease, they would be the same. Here is another one. Boop, 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 boop. If I folded from this way to that way, they would lie directly on top of each other, and that's a line of symmetry. Now you might be tempted to say, oh, I'm going to have a good time here. I'm just going to go across here and do a line of symmetry. No, because if I folded this onto that one, this corner would be sticking out and it wouldn't really work. So that's not a line of symmetry. So a rectangle only really has these 2 lines of symmetry. So I can go back up to my chart and get my pretty colors. Thank you. A rectangle has 2 lines of symmetry. There's only 2 lines I can draw where I can fold that shape over onto itself and it can match. Now if we're looking at rotational symmetry, same deal. If I rotate this puppy, let's say 90 degrees, it's actually going to look something like this. And that's not an exact copy of that. So 90 degrees is not going to cut it. But if I did a full 180 degrees and flip the thing clear over, it is going to look like itself. Look at that amazing drawing. And then if I flip it another 180 degrees, it's going to come back to looking at that. So a rectangle actually has two rotations. The order of rotational symmetry for a rectangle is 2. Now what's not on this chart is the regular pentagon, so let's have a look at it. The line of symmetry, there will be 5 lines of symmetry, because if I draw, my ruler my way, if I draw a line of symmetry here, I can fold either side over. You know what? The same is true if I draw one here, that's 2. If I draw one here, 3. These are all going to create matching copies on either side of the line, 4 and 5. So for a regular pentagon, the line of symmetry is 5. I got 5 lines or creases I can draw where I would get an exact copy folded together where they're the same. And the line of rotational symmetry, you're going to find, is also 5, because if I, let's see, 360 divided by 5, because I'm going 360 degrees equals 72 degrees. So every turn of 72 degrees is going to give me an exact copy of that. So I have 1, 2, remember this is a regular polygon, which makes this a lot easier, 4, and 5. So the line of rotational symmetry is, I should put RS there, is also 5. Okay, now, before you go on to these other exercises, come up and have a look here and see how many, use a ruler to draw all possible axes of symmetry. So you're just drawing the lines of symmetry for these ones. And remember, if you drew it correctly, a line of symmetry is going to mean you can fold it over and it's going to match up to each other. So have a go at those, then we can have a look at those in class, and then you can move on to these exercises here.